Hello guys, my name is Aditya and today we'll be exploring IRIS dataset using NumPy, Pandas, Seaborn, etc. So see, actually we have not learned we have learned NumPy, but we have not learned Pandas and Seaborn till now. This video is just to show you uh, why learning NumPy, Pandas, and Seaborn is actually useful when you are doing such kind of things. So we'll be using the NumPy, Pandas, and Seaborn library so that we can explore IRIS dataset. Now, first of all, what is IRIS dataset? IRIS dataset is a very famous dataset that all the machine learning beginners or maybe the data uh, visualizers or maybe data analyzers, they use it for practicing. Okay, it is just a uh, data set that has different types of iris flowers with their sepal length, petal length, sepal width, petal width, etc. These are features. Okay, so the link for this iris dataset is given below in the description, and you can download it from there. Or okay, I will just directly give the iris dataset here. It is downloaded from Kaggle dataset section. Okay, so I'll also give the reference below. Now keep this dataset, whatever you have downloaded, in the same location wherever this notebook is present. Okay, I have already kept it there, so let me just show you once. So my notebook is exploring iris, right? And this is the dataset. So let me just show you here. How can we take import the dataset here? Okay, so first of all we need some packages. Import NumPy as np, right? Import pandas as pd and import seaborn as sns. So let me run this cell. First of all, we'll be using these three libraries. Okay, and we'll be answering these 7 questions here. So this is how we'll learn. It's better that you download the dataset and you also create a notebook, so that once you get one concept, then you can try it out yourself by pausing the video and then play it again and learn the next concept. Okay, so first of all, reading a CSV file. How can we read a CSV file? So let us say we want to read a CSV file and we want to assign it to a variable called data. So pd dot read CSV is the function to read the CSV file. iris.csv is the file that we'll be reading. Okay, now this should be present in the same location, in the same folder where your notebook is actually present. By default the notebook is present in the user section, but it may be present somewhere else in your PC. So check that out and place it at the same location. Otherwise what you can do is you can give the full location here, full address of wherever this file is present. Okay, so let me just load this data. Okay, we are done. We have loaded the data. Now see, this is how we read a CSV file. Now looking into data, the first few rows. How can we look into the first few rows of data? So we can directly write data.head. It will give us the first 5 rows. These are the first 5 rows. Okay, and similarly if we write data.tail, this will show us the last 5 rows. What if you want to get the first 10 rows? Let's say, so we have to write here 10. The default value for head is 5. Okay, so it shows us the first 5 rows. So if we want to get the first 10 rows, we'll write 10 there, and here is the first 10 rows. Okay, now similar things happens for tail as well. Suppose if we want to see the the last 7 rows, then we'll write 7 here, and these are the last 7 rows. Okay, Now uh, what if we want to know, not just the, what if we want to get a data from somewhere in between, not just the first n rows or maybe the last n rows. Okay, we want to get the data from somewhere in between. So what we can write is data dot ilog. This is how we write in pandas. We'll be seeing this when we learn pandas. Okay, data.ilog means indexed location from, let's say, 20 to 60. This is my row index. Okay, and I want all the columns, so I'll just give a column here. I want all the columns from row 20 to less than 60. Okay, so here we have 20 to less than 60 up to 59, and we want all the columns. So this is how we can access. Let me just reduce this up to 30 so that it will look a little bit better. Yes. Okay, so this is how we can access the data from a dataset. Now this next thing is, what are samples, attributes and classes? So these rows in the field of data science, these rows are called samples. Okay, not only in the field of data science, but when we are handling such data. Okay, these rows are called samples, these are called attributes. Okay, and this is the class label. The class label is something that we want to predict. Okay, so given such sepal length, sepal width, petal length and petal width, we want to predict that it is iris setosa or something else. So I hope you understood what is uh, sample, attribute and classes. Now we want to know that in our data how many samples are there. The one thing is, when we actually print the tail, we also get the uh, uh, row number, right? That is the index of the row, that is 149, and we started from 0. So clearly there are 150 in number of samples. But a better way to do it is, we have already learned the shape function in NumPy, right? So we'll just do data dot shape. Shape returns a tuple. First is the row and followed by the number of columns, the number of rows followed by the number of columns. Okay, so we have 150 number of rows as we already discussed, and we have 5 columns, 1 2 3 4 and 5. Columns are called attributes and the rows are called samples. Now among those attributes, we can select any attribute as class label, but that should be something meaningful, and we are not going into how to select a class label or what should be the class label. Just for instance, we'll assume that this species is a class label. Okay, now we want to know how many classes do we have to predict. Like, suppose, like, if we have this sepal length, this sepal width, this petal length and this petal width, then it should be iris setosa or what. So we want to know how many number of classes are here. So what we can do is np dot unique data, and then we can write species. Okay, this will give the unique occurrences in this species column. Okay, only the species column. So these are the 3 unique occurrences. Okay, so either the flower can be iris setosa, or it can be iris versicolor, or it can be iris virginica. Okay, so this is how we can see. So we already learned what are sample, attributes and classes, and how many samples, that is 150, how many attributes, that is 5, and how many classes, that is 3. And what are the classes? These are the classes. Okay, now the next thing is how to get mean, standard deviation of sepal length, sepal width, petal length and petal width. So what we can do is np dot mean. There is something called as describe, pd dot describe in pandas, but we'll learn about it later, not now. We'll just use the numpy and we'll see how we can get the mean or standard deviation or variance of a particular column, okay, of a particular attribute. So sepal length, let's say data sepal length. So this is the mean, that is, this is the average sepal length, okay, among those 150 samples. This is the average sepal length. What if you want to get the average petal length? We'll just replace this with petal length, okay, and so on. What if you want to get the variance? We'll just replace this with the variance command that we have already learned in NumPys. If you are not familiar with NumPy and you are seeing this video for the first time, we also have a tutorial on NumPy. You'll find it here, okay. Now the next thing that we'll be going with is, see, these all things can be done easily with NumPy, just as I have done here, right? I have not run this cell, so this is the variance, okay. So you can try these things out with different columns and see what is the output. And the next thing that is, how can we calculate the sepal area by using, let's say, sepal length and sepal width? We know that area is equal to length into width, right? So we'll use the same formula here. Sepal area is assigned to, let's say, data dot sepal length into sepal width. Sorry, not this way. Data of sepal width. Okay, then we'll get our sepal area. Now let's see the shape of sepal area. Now I hope that this is an array, otherwise shape will not be returned. So it is returned, right? So it has 150 rows, and here nothing is given, but it has one number of, that is just 150 number of values in it, okay, 150 number of values in it. Sepal area, let me just print sepal area and let's see. So this is it, right? 150 number of values, and these are the index, okay. Now what if we want to add this sepal area into our actual data set? Then what we can do is, we'll just write data dot sepal area. This is actually the name of the column where we want to add it, right? And what we'll write, sepal area, this is the variable that we have created here, and this is the name of the column where we want to add this variable, okay. So after this, if I print data dot head, then see, we have our sepal area as well. Before we only had up to species, right? Only up to species. Now we have sepal area as well. So this is how we can calculate something, or we can form a column and we can add a column to a data frame, okay. Now in similar ways we can also do for petal area, right? I'll just copy this and I'll write petal area here. So after this we'll have our petal area, so let's just do this. So we have petal area as well. Now see, we can apply many operations, like suppose, say, if you want only those rows whose sepal length is, let's say, greater than 5 and the petal area is, let's say, less than 0.28, okay. So what we can do is, let's say we want to call that as new data, okay. New data is data where data sepal length is greater than 5, as I have said, right? And we want to use AND operator here, because along with this we also want that our petal area should be less than 0.28. But in pandas, this we are using pandas, okay? In pandas we cannot use this AND or maybe double AND. We just need to give a single ampersand, okay? And that will do. So data dot petal area is, let's say, less than 0.28, as we can see there, right? So, and we want our new data dot shape. How many elements will still be retained in new data? See, this won't change the data at all. It will just extract data, all the columns of data, such that the rows satisfy this property, okay? And it will store it in new data, but it won't change this data at all, okay? So let's see how much what is the shape of our new data. So it is 6 cross 7. Why 7? Because we have 7 number of columns. We have, before we had 5 number of columns, we added 2, so it becomes 7 number of columns, and there are 6 rows. We want to see which 6 rows, right? New data. I can just write new data. So these are the 6 rows with such indices, right? The 0th row, the 14th row, 20th row, 32, 33, and 36th row. Okay, so here we have greater than 5. This is the sepal length greater than 5, along with petal length less than 28, but still you can see here 28, right? So this is just the rounding off this. Whenever you are printing something, just say like you're printing a big thing, so it will just round it off, okay? But if you actually want to see what is the petal area for this row, then what we can do is data.ilog of 0, and we want petal area, right, from index location 0 from this, right? And we want the petal area column, this one. So it should print, see, 27.999, so it is less than 28, right? Sorry, 0.27999, so it is less than 0.28, right? So that is why it is included. Don't see that it is given here 0.28, so how it is less than 0.28, because the actual value is this is just the rounded off value, okay? Whenever you will be using in any kind of calculation, you will be using this value. So this was all about calculating the sepal area and petal area and adding it to the data frame column wise, right? Appending it to the data frame. Now let's explore some plotting, okay, using this Seaborn. Let us see how we can plot it. See, we just want to plot sepal area versus petal area, right? So what we can do is, we have already imported Seaborn as SNS, so we'll write SNS dot scatter plot. This is how you plot scatter plots, okay? X is assigned to data, which column? From data, sepal area, and y will be assigned to petal area. So if we just run this cell, okay, there is some error. Array length 1 does not match index 1 length 150. Okay, I have missed data here. So this is how we get a scatter plot, okay? Now this scatter plot does not make any sense. It just gives us how sepal area may be related to petal area. It is nearly linear, but not linear, not much linear. What if we want to separate it based on the class? So we can give a hue here, and we can write data dot species, as species is our class, right? So this is a better representation, right? So we have blue as the iris setosa, orange as iris versicolor, and green as iris virginica. So see, by just looking at it we can classify, right? If the petal area is less than 1, then it is definitely less than 2, let's say, then it is definitely sepal then it is definitely iris setosa. If it is somewhere above 2, and let's say, see this area from 7 to 9, okay, this area may be a little erroneous because there are some mixed values of sepal of iris versicolor and iris virginica here, but above it is clearly visible that it is virginica, and below it is clearly visible that it is setosa. So in midway somewhere it is versicolor, so it may be linearly separable with a very less amount of error. As we can see that this is very less amount of error here, right? Very less. So this is a way to visualize the data. Okay, we'll be learning more when we are actually when we'll be actually learning this Seaborn and Matplotlib, and we'll also start the next day from learning pandas in detail. So stay tuned. This video was just to motivate you guys, so that you guys are not learning something random, some random things. Whatever you are learning, you'll be using it somewhere. Okay, if you are doing such kind of projects, it will be really helpful. So keep watching guys. I hope you like the video. If you actually like the video, hit the like and the subscribe button. Also share it with your friends. Have a great day ahead and hope to see you soon. Bye bye.